One of the most well-known stars in the sky is undoubtedly Vega, one of the brightest stars in summer. At certain points in history, Vega has also been the brightest pole star. This star rotates at incredible speeds, making it one of the most studied by astronomers. It was the first star ever photographed and serves as a baseline for measuring the brightness of other stars. It's no wonder some say Vega is the most important star in the sky after the sun. So there's a lot to discuss, so let's take it step by step because today we'll be talking about Vega. In 1840, English photographer John Draper photographed the moon in what became the first astrophotograph in history. The technique used was the daguerreotype, one of the earliest widespread photographic techniques of that time. It involved using a silver-coated plate, sensitized to light through exposure to iodine vapors. During the photographic exposure, light left an imprint on the silver, creating the image. In this way, Draper obtained the first astronomical image in history. 10 years later, on July 17, 1850, astronomers William Bond and John Whipple repeated the process, aiming their lens at a star, Vega. But why Vega? Vega is a very bright and important star, always at the center of astronomical studies. It is one of the main features of the summer sky, and the photo was taken in July, making it an obvious target for such an experiment. On summer evenings, three very bright stars form the so-called summer triangle: Altair, representing the head of the constellation Aquila; Deneb, representing the tail of the swan; and Vega, the third vertex of the triangle. Vega is the brightest star in the constellation Lyra, the only musical instrument in the sky in Greek mythology, associated with the lyre of Orpheus. The lyre used by Jason and the Argonauts to distract sailors from the siren's song is easily identifiable on summer nights, appearing near the zenith, directly above the observer's head. Next to Vega, a small parallelogram formed by four dimmer stars represents the lyre itself. Vega, known as Alpha Lyrae, is the brightest star in this constellation. Its name, like many other stars, comes from Arabic through the medieval transcription of the phrase al-Nasr al-Waqi, which means eagle or falling vulture. In Arab and Indian cultures, the constellation Lyra was represented as an eagle or vulture. Due to its brightness, Vega was highly regarded by many ancient cultures, such as the Babylonian and Roman, where its appearance in the sky marked the beginning of the wheat harvest, generally between June and July, when the summer triangle becomes visible. About 14,000 years ago, Vega was the pole star due to the precession of the equinoxes, which causes the Earth's rotational axis to wobble in space in a cycle of about 26,000 years, shifting the celestial North Pole. Around 12,000 BC, Vega was the pole star, located only 5 degrees away from the celestial North Pole. This role will be taken up again by Vega around the year 14,000. Among the stars that can become pole stars, Vega is the brightest. In 1805, Jesuit astronomer Giuseppe Calandrelli attempted to measure Vega's distance using stellar parallax, a technique that measures a star's position 6 months apart to calculate its distance. However, the first accurate stellar parallax measurements were obtained in 1838 by German astronomer Friedrich Wilhelm Bessel. Vega is about 25 light-years away from Earth. Vega is a main-sequence star of spectral class AO with a white-blue color. Its luminosity is about 50 times that of the Sun, thanks to its mass being double that of the Sun, 0.16 times. However, mass alone doesn't explain its high luminosity, which is also due to its rapid rotation, with a speed of about 175 km/s at the equator. In comparison, the Sun rotates at about 2 km/s and takes 27 days to complete a full rotation, while Vega takes only 16 hours. Vega is an extremely oblate star with a diameter at the equator about 20% greater than at the poles due to its rapid rotation. It is so close to breaking speed that the star's material barely holds together. Being so bright and easily observable from the northern hemisphere, Vega was chosen as the standard for calculating the luminosities of other stars. The apparent magnitude of stars is measured relative to Vega, which has a defined magnitude of 0. The future of Vega includes a relatively short lifespan due to its mass, about 3 billion years compared to the Sun's 11-12 billion years. Currently, Vega is about 500 million years old and will continue to shine brightly in our skies, lighting up summer nights with its bright light. Thank you for following along. We invite you to subscribe to the channel and activate the notification bell so you don't miss the next videos.